Alright, Math 10s, this video comes out of lesson 1.4, which is called Surface Areas of Right Pyramids. And we'll actually also do right cones in a moment, but let's just talk about pyramids for this first one. First of all, recall that the area of a rectangle is length times width. I think we're all pretty good with that one. The area of a triangle is 1/2 base times height. And the area of a circle for later on is pi r squared. So those are kind of taken as known from your junior high stuff. Now, a right pyramid basically means that you have a base, and then straight up from the base, you have your sides. And so if we have a right square pyramid, simplest example probably is a square on the base, and then 4 equal triangles that come to a point straight above the center of the base. If you change the base to some other polygon, like a pentagon, my apologies for my drawing of a pentagon, pretty gross, but same idea. You have a 5-sided base in that case, and then 5 triangles coming to a point in the center. And you could have a hexagon, octagon, whatever. It turns out that rather than finding the area of each of those shapes individually and saying, okay, here I've got a square and then a triangle, 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 or here I have to find the area of a pentagon and then 5 triangles and adding them together, it turns out that there's a nice smooth formula. A tetrahedron, by the way, which you run into a couple times in this next couple lessons, actually just has a triangle base and then 3 equivalent triangle sides. So in the end, you end up with 4 sides that all look the same. Again, the drawing is a little tough in 3D, but we'll show some 3D pictures out of your textbook. So any pyramid that's a right pyramid and has a regular polygon base, meaning that its sides on the base are the same, whether it's a square, a triangle, a pentagon, or something with more sides than that, follows this little formula here, that the surface area equals 1/2 slant height times the perimeter of the base plus the base area. So it's a bit of a shortcut. Really what it amounts to doing is finding the area of the base, as you can see there, and adding it to all of those triangles that go up to the top. But this just does a little shortcut of that by saying, okay, well, the perimeter of the base allows you to do all the triangles at once. But there's this new idea here of the slant height. So my next example is going to focus on, like, what is the slant height and how do we find it if it's not given?